Selecting the right body style was important to achieve the performance goal of 0 to 60 in less than 3.5 seconds. A two-door sedan allowed the engine and seats to be set back, moving more weight to the rear wheels. Decided a quality fiberglass body with a moderate chop top was better than trying to find a quality steel car and chopping it up. Note the oak reinforcement in the original Ford body. The fiberglass replica uses oak reinforcement in the same places around the door and window, as well as around the rear and roof supports. This is one of the molds used that was made from an actual steel Ford body. This quality bodybuilder joined the fiberglass parts while they were bolted to the car's chassis. This kept distortion in check as the body cured. The motor setback required a recess in the firewall for the HEI ignition. Tubs were also needed for the 16.5-inch section width rear tires. The fenders and running boards are all separate and have to be fit to the body. The running boards are OEM type rubber coated steel. The fenders are fiberglass. The hood top louvered sides are also steel. They used a special black resin. The black body was set in the hot Carolina sun for a few days to allow it to be the hottest it will ever get, to avoid fiberglass imprinting later. They recommended using lighter, more reflective paint colors on the car. The body was block sanded by hand with finer and finer paper before priming. The body was primed with a number of coats of paint. After some additional sanding, the bottom and firewall were painted the final color and clear coated. The base color paint was applied late one evening, then flames started early the next morning since the clear coats had to be applied within 24 hours. The flames are done with thin masking tape by hand, a very steady one by Kyle Bond. After making the outside of the flames, masking paper was placed on areas not to be painted flame color. Then flames were sprayed black, the color of the pinstripe, being careful to cover the edges. Kyle is shown in the upper right photo putting 1/8-inch wide tape over the cured black paint to make the pinstripe. A very tedious task that took several hours. Note the back brace. When the pinstripe taping was finished, the flame color, a darker silver than the body, was sprayed. Then the pinstripe masking and all other tape removed. When the darker flame paint cured, which only took a short time, the final multiple clear coats were sprayed to complete the job, all done within 24 hours. Scott, who fit most of the body, sprays undercoat on the bottom side of the fenders and running board. It's a driver, not a trailer queen. With the body finished in 2001, Street Rod Builder magazine published an article about the owner and paint artist Kyle Bond. He was listed as one of the best young builders, along with Chip Foose and a few others. These are the pictures from the magazine. With the car now in my garage, the 1,000+ hours of my effort needed to complete the car got started. There are many items behind the dash that did not exist in 1934, like air conditioning, an extensive fuse panel, and a full complement of gauges. They never would fit behind and under that small dash. A dash extension was needed. Made it from oak, which was easy to work, and to attach the finished leather. Complete details are on our website. From the rough wood frame, the finished product can be appreciated when covered in the interior leather. Note the oval theme was carried out with the switch panels, vintage air controls, and outlets, even the rear view mirror. In this view, a sound wall in the rear is nearing completion. It was constructed from birch plywood. More details are covered in the video on the electrical systems. The sound wall looks great, covered in interior leather. The 34 interior is surprisingly narrow. Considered seats from a junkyard, but it was difficult to find narrow buckets that fit well. Elected to purchase these from Glide Engineering. They also have excellent mounting arrangements. We selected the passenger side tilting from the front base to get access to the rear. They were also easy for our upholsterer to cover. Don't just bolt seats to a fiberglass floor. Made a steel support that bolted to the side frame rails. Even the anchors for the safety belts went through holes in the steel support. Note the welds. Many welds were made in the car. This brace was tack welded with the parts in place and then moved to make full pen welds away from the vehicle. The low car shifter and emergency brake handle required removal of a good deal of the floor in that area. Decided some 3/32 thick aluminum would make a good cover, but how to form it? On the right is a die made from 2x6s. The 1,500-pound press was made by jacking up the side of my S10 pickup. Be careful if you try this, it is dangerous. Slowly lowering the jacks, the finished shape was formed in the die. A 5-pound hammer shaped the press part, making a perfect fit. On the right is a cover bolted to the floor. A unique product available for only a short time, water-based silicone, was used to fill the seams. It is only available now as an industrial product. Used a professional company to make the interior. Had a 6-month waiting list, but it was worth it. Since I had developed a detailed work schedule and was spending 12-hour days, thought I would be ready in 6 months. Barely made it, with much still left to do. Note the headliner. It was a pleasant surprise. These 3 fellows were artists with leather. I had offered to make the armrest and was told, "Don't bother, we'll do it." They matched the flames, and the top of the flame protrudes as an armrest and a door pull. Very creative. Decided to add safety pins for the suicide doors. They have alarms to remind you to use them. Couldn't find taillights I liked. Also hated to cut into the finished smooth look in the body. Saw an Australian hot rod magazine with taillights mounted in the bumper. Thought the bumper idea was a good one, but wanted to mount them higher. Taillights were made from OEM style stainless steel 1934 Ford cowl lamps. The odd shape of the cowl bracket made the shape of the boxes needed to mount them to the curved stainless bumper a complex shape. After making paper templates, cut stainless plate with plasma, MIG welded and ground the seams, polished the finished assembly. Added 55-watt fog backup lamps underneath. Saw this Nerf bar design in an old hot rod magazine. Made a pattern, and a friend with a CNC plasma cutter made a sample from sheet metal that I could test fit. He then cut them from 1/2-inch thick stainless. The company that chrome plates bumpers polished the stainless so it looks like chrome. There is no chrome on the car. It's either billet aluminum or stainless steel. Saw this approach at a car show to keep the air conditioning and heater hoses neat. The owner said he made it in his machine shop. Not having a machine shop, made this from 1-inch thick aluminum, cut with a saber saw and metal hole saws. It attaches to the Dan Fink hood brackets. Little extras make a big difference. The third brake light was integrated into the body. Small billet wipers fit perfectly. Remember, it's a driver. One got caught in the rain a few times, but they work well. The mirrors are from Valley Automotive with very neat brackets. These are some photos of the finished car. Note the clean look from the rear with no taillights cut into the body. The stainless bumper looks great in the rear, but the Nerf bars are what was needed for the front. We used our 150 amp MIG welder for many items on the street rod. The argon-based shielding gas comes from a large cylinder chained to the wall. To reduce the blast of gas at the weld start, we use our gas saver system, the first use of this patented system. It makes the gas cylinder last over twice as long and improves our weld start quality. It simply replaces the gas delivery hose. The patented gas saver system is a simple, inexpensive gas delivery hose with a small ID and a peak flow limiting orifice. It reduces wasted stored gas by over 80%. It retains the system pressure to supply enough start gas to purge the weld start area and to compensate for flow restrictions that occur while we're welding. It has no moving parts to set or wear. Thousands are in use in industry. For more information on constructing and finishing the car body or about our welding gas saver system, visit www.netwelding.com. Thank you.